We're now going to look at multiplying a binomial by a binomial. This tends to be the bread and butter of what we can do with polynomials. I've said a lot of our job is making things look like things we know the answers to already. We change the way things look. And going forwards and backwards with binomials to monomials becomes very important, and a lot of our complex things will simple down to this. So what we mean by multiplying a binomial by a binomial is we'll have an individual binomial, x plus 2, and put it in parentheses, times another binomial, two terms, x minus 3. Now the method we will use is called FOIL, which is firsts outer inner and lasts. Firsts are those two. And so the first in this case is x times x. Outers are the things on the outside. And so that is x times negative 3. Inners are those two bits on the inside. And so my inners are 2 times x. And then lasts are the things that appear at the end of each binomial. And so that's 2 times negative 3. And so what we have is the first take care of the first thing that appears in each binomial, and we multiply them by each other. The outer are the things on the outside of the pair. The inner on the inside of the pair. And the last are the last things of each binomial. We bring these over. So x times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. And negative 3 times 2 is negative 6. Well, these are each part of a term, so we can add these together. So x squared minus 3x plus 2x minus 6. But notice, these middle terms, you'll hear that a lot, middle terms, are of the same degree. So we will simplify. Negative 3x plus 2x is minus x minus 6. And FOIL usually produces a trinomial. If the binomials have the same degree and the same variables, and their terms line up, we'll get trinomials. And a lot of what we'll be doing is multiplying in and out of trinomials. So we'll look at a couple examples of foiling, which is our main techniques for it. So we'll look at the binomial x plus 2 times 2x plus 3. And so our firsts is 2x times x and then our outers, first, now I'm going to do my outers, which is an x and a 3, So I'm going to put 3 times x. I'll put my number first. Now my inners, let's get a slightly different color. So that's inside and that's inside. So notice how I've got the inside here, so that's 2 times 2x. And then in my lasts. So that's a last, and that's a last, which is 2 times 3. So 2x times x, using my exponent rules, is 2x squared. 3 times x is 3x. 2 times 2x, again, using my rules, I get 4x, plus 2 times 3 is 6. But notice, these middle terms again are the same degree of x, so I can gather like terms. So 2x squared plus 7x plus 6. And that's the pattern we're going to see in foiling, is that the middle terms are special. And to the point that we say, look at the middle terms, look at the middle terms. That specialty shows in when we start squaring binomials. So if I have a binomial x plus 5, and I square it, well, that's saying the same thing as I'm going to multiply x plus 5 times x plus 5. And so I'm able to FOIL this. So my firsts, I'm going to underline in red, x times x my outers, that's on the outside, and that's on the outside. So that's 5 times x. My inners, that's on the inside, and that's on the inside. That's 5 times x. And then in lasts, which that's last, and that's last. The 5 is our lasts. So that's going to give me a 5 times 5. So now if I complete my mathematics here, I get x squared plus 5x plus 5x plus 25. Again, the middle terms repeat, and I get 10x in the middle and plus 25. Now, you can always do a square. Got crazy pen going on. I think the batteries are almost dead on it. But you can always take a square and turn it into a multiplication of two binomials. But some people see a pattern in this and they'll rush right to the pattern. So the thing to think of, notice that that matches the first number squared. And this matches the last number squared. So the pattern people say is if you have some binomial squared, the answer is always a squared plus 2ab plus b squared. And that's the overall pattern. And the 2ab comes through. If you notice up here, because in squaring you have the exact same thing in the middle terms, that's the same as multiplying by 2. I always have a hard time memorizing this, so I just FOIL it back out. I write it all back out so I can see each part. We can do this with the a plus b, so we can see where people get this rule from. So scroll down a bit here. If I take a plus b and write it out as a pattern of 2, my first gives me a times a. My outers gives me a times b. My inners gives me b times a. I'll write it alphabetically though. And my last gives me b times b. So a times a is a squared. I have an a times b and an a times b twice. So I write that as 2a times b. And at the very end I have b squared. And so that's a pattern you'll see a lot of other people go for when they talk about squaring binomials. I always write it out the long way, just because it saves me from memorizing it. If you use other resources or whatnot, just be aware they'll tell you both ways. But that is a special form of multiplication of polynomials. In the next video, we'll look at multiplying longer polynomials, and then I'll set up some homework so that we can get comfortable with multiplication.